make use of limits.h, and you can find out that what is the maximum limit value which is supported on your system. Okay, so let me just show you the limits.h also. Man limits.h. So it shows all the limit values. Say open underscore max, maximum number of files that one process can have open at any one time. So minimum accepted value is given as POSIX underscore open underscore max. Let us just scroll down. We may get that value even. So you can use this constant value in order to check that what is the maximum number of values it is supported. See, look at this. So this POSIX underscore child underscore max maximum number of simultaneous processes per real user ID, it is 25. So at the maximum we can create a maximum of 25 child process. So after that if we try to create, it will generate an error. So like this, for each and every constant there will be a maximum limit value. Fine. So these are POSIX 1B limits. You need not have to by heart each and every limit. So certain limits that you can easily remember, like child underscore max, and then file underscore open underscore max, and then arg underscore max, path underscore max, name underscore max, link underscore max. So all these things you can easily remember. So such things you can remember. Very rare cases that they are going to ask you to say that what is the maximum number of canonical input queue which is supported. So then you should be remembering this limit name. So or otherwise usually they are going to ask in a way that at least mention any 5 limit names, and with the help of the program you show that how you can check the limits on the system. So that is how we can check the maximum number of child processes which are supported on the system, the maximum number of files that can be opened on the system. In this way they are going to ask the question. Okay, so I'll show you some of the syscon limit values and pathcon limit values. So for syscon limit values, so you are going to use, as I told you, that you are going to use underscore sc as the prefix, right? So we just saw that POSIX underscore child underscore max. So when you want to check this limit on system wide basis, you'll be using underscore sc as the prefix. The maximum number of child processes that may be owned by a process simultaneously. So this is a system-wide limit, right? So this is on not on per file basis. You can't use this limit name for per file basis. So if you are checking the limit name for per file basis, so there are some category of limits that you can check on per file basis. So path underscore max. So that is the maximum number length in bytes of the path name. So that is supported on per file basis. If it is per file basis, you'll be using underscore PC. And underscore name underscore max. This is the length of bytes of the file name. So like this, you can find out that what is, whether it is system-wide limit or the limits on file basis, and you can use suitably either underscore sc or underscore pc. Okay, this is a simple program in order to check the limits using syscon, pathcon, and fpathcon. I'll be showing this program to you in the next class. I have not yet done this. Fine. Okay. Uh, this is how you can make use of these limit names in order to check what is the maximum limit values which are supported on the system. So that is just a moment. Hello. Hello, Hema. In class 10 to 11 ಇದೆಯಪ್ಪ ಸಾರಿ 10 to 11 ಕ್ಲಾಸ್ ಇದೆ 11 ಬರ್ತೀನಿ ಓಕೆ ಫೈನ್ ಓಕೆ yeah so this is where you are going to make use of the syscon in order to find out that what is the maximum number of files that can be opened on the system. So if it is not defined, the value will be equal to -1. Right? If it is defined, so then it returns the value. Okay. So the value that it returns will be stored in the result. So here you are going to call the p-error function. So that is p-error function can be called in order to print that it is an error under syscon function. So here we have used pathconf and fpathconf function also. I told you that the difference between pathconf and fpathconf is that in case of pathconf we'll be providing a path as the parameter, the first parameter. In case of fpathconf we'll be passing a file descriptor as the parameter. So here in case of pathconf we are passing the root as the path name, and this one it is file descriptor as 0. So you might be knowing when Unix also you have studied that the file descriptor 0 indicates standard input or 1 indicates standard output. Right? So this is the standard input that you are using, and you are checking whether the path max, what is the value of path max, right? So if it is equal to -1, it will be generating an error, else it returns some value. So in the next class, I will be executing this and showing you where it becomes more clear for you. And then sound restricted, whether it is supported on that particular file or not, that you are going to check with this. So next is POSIX FIPS standard. So FIPS standard is the Federal Information Processing Standard. So this is a restriction on POSIX standard. So means that these features like job control, save set UID, GID. So these features may be supported on a POSIX system or not. But if it is FIPS standard, POSIX system which is conforming to FIPS standard, then obviously all these features will be supported. So that is why it is the restriction on POSIX standard. Job control will be supported. Saved set UID and GID will be supported. Long path name is not supported, right? And then POSIX churn restriction will be defined, and V disable symbol must be defined, and N group max symbol. So that is the supplementary group to which a process can belong is at least 8, and whenever a read or write API is executed and if it is interrupted by a signal, so then it has to return the number of bytes that has been already read or written. Okay, so read and write API are used in order to read from a file or write into a file. So if it is interrupted by a signal while reading or writing, so then it will be returning the number of bytes it was read or it had written before the signal could be generated or before it's been interrupted. So next, the group ID of the newly created file must inherit the group ID of the containing directory. So if you are creating a file newly, so then the group ID of the file will be according to the group ID of its containing directory. So suppose that if you have created a directory and the group ID is 5, and if you are creating a new file, So then the group ID of the new file will be 5 itself, because it will be inheriting the group ID of the directory. So next is Xopen standards. So Xopen is the standard that was created by Xopen organization, which was formed by a group of European companies to propose a standard for Unix as well as the C programming language. So they proposed, they came up with a project called Common Open Software Environment in 1993 in order to provide a single Unix programming interface that would be supported by all vendors. So this was quite successful, and the application that conformed to ANSI and physics would also be conforming to Xopen standard, but not necessarily the vice versa. So that is the systems which are conforming to Xopen standard were not supposed to be conforming to ANSI and physics standard also. So this is about Xopen standard. So next is Unix and POSIX APIs. So API is nothing but it is similar to functions. So for all the features, for example, if it is to create a child process, so we have an API called fork. So if you want to open a file, we have an API called open. If you want to read or write, you also have a API. So almost all the functionalities which are supported on the system, it is with the help of the APIs that can be done. So API is nothing but it is similar to the function, but what makes difference between an API and the function is that, so function, in case if you are executing a function, there won't be context switch that is going to take place, because all APIs that you are going to execute on Unix system, so it will be executed in a protective environment. So that is, whenever a user executes his program, an application program, so then the context, that is the context in which the user will be executing, will be in the user context, right? But when he tries to execute any API, so then the context of the user will be changed to the kernel mode, right? There will be two modes in which the user will be executing his program. So that is a user mode and kernel mode. So if he is executing any common statements apart from API, so then he will be executing in user mode. So if at all he tries to execute any API, then obviously he will switch into the kernel mode in order to execute the API. The reason is that whenever you execute the API, you will be accessing the resources of the kernel. So accidentally the user should not misuse the resources of the kernel. So that is why all APIs will be executed in kernel mode in a restricted mode. Okay, so Unix supports a lot of APIs. So the APIs can be categorized as to determine system configuration and user information. You have some set of APIs. In order to manipulate the files, we have certain set of APIs. And in order to create the process and control the process, we have a set of APIs. For inter-process communication, also we have some set of APIs, and even for network communication. So as I told you that whenever it needs to execute an API, the context of the process will be switched from user mode to kernel mode, and once after the execution is completed, it has to return back to the user mode. So there is a drawback that whenever you execute the API, it is time consuming for this context switch to happen. So that is why if it is a time critical application, then it is better to use the system calls only if it is necessary. So you may understand what you mean by time critical applications. So real time applications also we can call them as. Next is POSIX APIs. Almost all the POSIX APIs that POSIX has, I have been telling you that POSIX is the standard for Unix. So whenever you standardize any system, it's not that you'll be bringing a new system itself. So obviously, even in case of POSIX also it is the same. So POSIX, what are the APIs that you are going to find in POSIX? So obviously they are derived from Unix, but whatever the shortcomings that we can find in Unix, that can be eliminated using POSIX APIs. And the behavior of Unix APIs um, is as similar to that of Unix APIs. But if at all you want to confirm that you are writing a program which is conforming to POSIX standard, you will be including these statements, hash include statements. So next is the development environment of Unix and POSIX. So you can find almost all the APIs under unistd.h header file. And as I already told you that all header files are not stored as .h. So that is as headers. Instead, they can be stored as files, and almost all header files are stored under sys directory, right? And all special data types are also stored under sys directory. And p error function, I showed you the p error function, so it is defined under stdio.h, right? Okay. And POSIX 1.1b and Unix API object code, it is stored under libc.a and libc.so. So we know that whenever we need to execute the program, you make use of the executable code. So that is, the compiler is going to make use of executable code. So since all these executable codes can be found under libc.a and libc.so, you don't need to specify the location of the object codes. But certain network communication APIs will be storing the object code in a special library on some systems. So that is about the POSIX 10 development environment. So that is, you can find all the APIs on unistd.h, and all the header files will be stored under sys directory, and you can find p-error function and on stdio.h. And only some network applications you don't find the executable code on libc.a or libc.so, but rest of the object code you can find under these two directories. So you don't need to specify that where to find the object code. So next is API common characteristics. So the common characteristics of API is that I told you that APIs are executed in a restricted manner in the kernel mode itself. And any API, once after execution, it will be returning the value -1 only if it fails in executing that API. Else it will be returning a different value, right? So whenever the API fails in execution, so it will be returning a global variable called ERRNO with an error code, right? So we can check that what is that error code. So by using str error function. So you can either use p error function to print the diagnostic message. So if you call p error function, so it will be printing the diagnostic message. So you can also pass whatever the error number it returns into str error function, so which gives the actual reason that why it has failed, because each error number is associated with an, that is the description of the error. So for example, so each and every error code, so these we call it as error code. So error code will be associated with an error number and with the description of the error. See p error syscon, right? So this syscon will be returning some value. So what is the error associated with this syscon function? can be printed as a diagnostic message in case of P error. So you can either call, once the API fails in execution, you can either call P error or str error function. For P error, you can just pass the function whichever it failed, or the API whichever it failed as the argument. For str error function, you will be passing an error number as the actual argument that will be returned through the API when it fails. The next str error function returns diagnostic message string, and user process may print that message in its preferred way. In the next class, I'm going to show you how to do this, and possible error numbers, error code, and the message associated with that you can find in error.h header. So if you want to make use of this str error function, you have to include this header file, and you can print the diagnostic message. So this is about the API common characteristics. Even this is also an important question which will be asked most of the times. So what you can write is, you can say that, so whenever any API is executed, so if it is successful in execution, so it returns a positive value, else it will be returning the value as -1. So once the API fails, you should get to know that what is the reason behind the failure of the API. So then you are going to make use of P error function or str error function. So str error function, you can pass an error number as the argument, and you can exactly find out that what is the error associated in executing the API. And all these error code are defined under error number.h. So with this I'm going to complete this chapter. So with this completes the first module, right? Any doubts with respect to this? Any doubts with respect to this?
No, ma'am.
All of you have understood?
Yes, ma'am. Yes, ma'am.
Do you feel the subject to be easy? Do you feel the subject to be easy?
Yes, ma'am.
See, only in the first chapter you have to by heart certain codes. In the second chapter onwards, it is completely like concept based. You can understand it in a easy way, right? So only in the first chapter you need to, like, if you practice writing those codes for some time, you can remember, right? So I'll be posting some module wise questions also, so that you can see that how you can in what ways that you are going to get the questions of. Okay, so with this I'm going to complete this class. Okay. Thank you.
Thank you, ma'am.